All right, so the topic of our talk today is security code analysis, is for everyone. A little bit of introduction about ourselves. I am Masuma, and I have my colleague Gal. Both of us used to work for Gemalto, a digital security company which got acquired a few months ago by Thales Group. So now both of us work for Thales Group. So you may or may not have heard about the company because we mostly do business to business, and we provide security solutions for governments, banks, and enterprises. Now, since we are a security company, before we deliver our products, we have to go through several layers of security. So one of the layers of security that we go through is security code analysis. So this is the agenda of our talk. We'll start off with some background, then we'll jump onto what is security code analysis, and we'll talk about different strategies of security code analysis. We'll talk about static code analysis and dynamic code analysis. And then we'll also talk about DevSecOps and how you can integrate security code analysis into your DevSecOps model. Then towards the end, we'll talk about if security code analysis, is that enough for you or do you guys need more? And of course, we'll take questions along the way or towards the end. So let's start with some background. So we know that software has become a very crucial part of our lives. There's software all around us, and especially in the past decade, it's grown exponentially, right? And these modern software systems are complex conceptually itself, and especially when you start implementing them, they become really complex because you could have a lot of microservices, a lot of interoperability between these microservices, you can have big data. So that leads to infinite possible permutations and combinations in your code. Now, also in today's world, we have so many different contributors to your software, right? There's people from different regions, there's people from different backgrounds, different mindsets, different level of expertise who are contributing to your source code. And that affects the quality of your software. So now when we talk about quality, we generally don't, especially when you're talking about the implementation level quality, we generally don't think about security. When you're trying to program a code, you don't think about security. But the fact is that quality and security, they do go hand in hand. If your quality is compromised, your security is also compromised. And if you make sure your quality is good, your security also strengthens. So imagine now you have a lot of implementation level bugs in your software. So those bugs are nothing but weaknesses in your software. And an attacker can exploit that weakness and create a breach, right? And we all know that it's just one weakness in your application that's going to cause a breach. Okay, so now assume you had a breach. Now what are the consequences you'll have to face as an enterprise if you had a breach? The first one is, of course, you have loss of credibility and trust. And we all understand that trust that's once lost, it's very difficult to gain back. And that will lead to loss of customers, right? If your, say, service is down because of a breach or your customer sensitive data has been compromised, of course, your customers will try and find alternative products in the market that they can trust more. And again, that is going to lead to loss of revenue for you. And not to mention, you'll also have to pay fines. They could be FCC fines or they could be GDPR fines, and they're pretty high. And again, that could just be a surface level cost. You may also have to pay for legal fees. You may have to pay for investigations, and your insurance premium will also spike up. So now, having said that, how do you avoid these breaches, right? So for that, you have to take really strong measures from your side as much as you can. to mitigate these breaches. And one of the things that you can do is security code analysis.
So we went over what security code analysis, why we need it. So let's go quickly why we need it. So we want to find any problems we have in our code, any security issues, very early in the development stage. And by finding them, we want to deliver more secure software to production. If we find our problems early, we will minimize our cost of future breaches. The earlier we find them in the development cycle, the cheaper it's going to be to fix them. And we want to advance best practices in our team. We want our team to think security. We want it to be part of our process as our team. So what is actually security code analysis? So it's basically a method to examine your code or your application. It's nothing new. Before we had automated tools, we used to do it manually. People used to do code reviews, manual code reviews, or pen testing, or hire hackers maybe to check your code. But with today's tools, our application becoming a lot more complicated, and we have millions of lines of code, it's almost impossible to do it manually. So today, we have automated tools to do that, and they will highlight where your problems are. So let's look at two main strategies for code testing, static and dynamic. So first is static. So a static approach is a white box approach. So this approach will check your code from the inside out. Obviously, it will require your source code because it's checking it from the inside out. And you will find vulnerabilities very early in the development cycle. You can run it every time you want to deploy a version, or a lot before every time you integrate new code into your system. Obviously, it's less expensive to fix the vulnerabilities because you find it very early in the development cycle, but it cannot find any runtime issues. The good thing about it, these tools support a lot of software. The other side is dynamic application security testing. So that's a black box approach. It's more like a hacker will test it. It doesn't know what the code is, and it will check your application from the outside inside. Obviously, it requires your running applications, so you can only use it on later development stages. Because you find it later, it might be a lot more costly to fix any vulnerabilities you have, but you can find any runtime issues you have. The downside is it won't support all kinds of applications.
So as Gal mentioned, there are two strategies that we'll talk about here. I'll start with the first one, which is static application security testing. I'll also interchangeably use it with static code analysis, and the short for that is SAST. So now what is SAST? As she mentioned, it's a white box testing. So you look into your source code, like how a developer looks into the source code, and you scan it line by line. And you see if there are any vulnerabilities in your source code without having to run the application. So that's why it's called static, right? All you need is a static piece of code for that. And of course, humans are very good at finding issues. But now when your application scales to a larger scale, then that's when you have SaaS tools to do your job. So let's see what are some of the vulnerabilities that SaaS tools can find. Of course, this is not an exhaustive list, but these are some of the top ones. And some of these are also in the OWASP top 10 list. So let's start with memory corruption. So in that, we'll start with buffer overflow. So buffer overflow, what happens is when you are trying to write to a fixed length buffer, but your program overwrites it. So it writes in adjacent memory spaces. Now that can lead to catastrophic effects. So what can happen is, first of all, your application can crash, or even worse, an attacker can find a way to run some arbitrary code and take control of your application. So that is something that SaaS tools can pretty easily detect, and they have evolved pretty well to detect those kind of issues. The next one is buffer overreads. I'm not sure how many of you have heard of the Heartbleed vulnerability that happened back in 2014. That was a result of the buffer overreads vulnerability, which was not detected for a while. So what happens in this, when you're reading from a buffer, the program returns you more information than it's supposed to. And that could be private keys, that could be any sensitive data like passwords or session cookies. So that's a pretty, that used to be a very underrated vulnerability back in the past, but now it's a very critical bug which should be found and fixed. And again, these SaaS tools, sometimes they may not be able to detect these kind of vulnerabilities because sometimes it's hard to find the tainted data. But they have evolved and they have found heuristics on how you can find these kind of bugs and fix them. The next one is injection. And again, that is the number one on the OWASP top 10 list, and it's been there for a while. They say that about 2/3 of the applications are vulnerable to injection attacks. So that one is a very critical one to find and fix. And SaaS tools do a pretty good job in finding these kind of vulnerabilities. So one of the injection attacks is cross-site scripting, where you have a user input and you fail to sanitize it and it's being used in a dangerous way, which could execute some arbitrary code or malicious code. That will lead to cross-site scripting attacks. And we'll talk about it later in the later slides, how static code analysis can find these kind of vulnerabilities for you. The next one is cross-site request forgery, where the user is authenticated in a session and he's tricked into performing an action which he doesn't intend to, and that could lead to some bad consequences. So for example, he's logged into a bank account, right? He's already has a session. And say he clicks on a link or a button, and that leads to some accounts, some amount from his account being transferred to the attacker's account. So he didn't intend to do that. So one of the ways to fix that is using XSRF tokens in your code. And some of these SaaS tools, depending on the framework and the language, can find these kind of vulnerabilities. The next one is SQL injection, where again you're taking user input, but you fail to sanitize it or verify it, and you're directly using it into a SQL command. Now, if an attacker enters a bad script, a SQL script, say he said that, hey, can you update my bank account amount from, say, $1,000 to $10,000, and that got executed in a SQL command. So that's an attack. And that, again, SaaS tools can find a way to detect those kind of problems in your code. The next one is sensitive data exposure, and that's again on the OWASP top 10 list. So what happens, sometimes we forget to encrypt our credentials, and you may have hard-coded in your source code. So SaaS tools can pretty easily go and find those for you, and it'll prompt you to encrypt those or externalize those credentials. The next one is weak hashing. So there are some hashing algorithms, for example, the MD5 or even SHA-1, which are very old and they are broken today. And if you use these algorithms, an attacker can easily find a hash which is equivalent to your original file's hash, and they can send a malicious file over, right? Because computers today are pretty fast and they can generate the same hash code for any other hash. So if you're using a weak hashing algorithm in your code, the SaaS tools will look for it and they will prompt you to basically use a stronger form of algorithm there. The last one on my list, of course, this is not an exhaustive list again, but the last one is null pointer exceptions. And again, this is a little bit underrated one because this could also lead to a security attack. Now imagine you have a piece of code that can throw null pointer exception and you forgot to catch it or you forgot to handle it. If an attacker can cause that null pointer exception, and if you have a authorization code or security piece of code after that, somehow that could get bypassed and the attacker can bypass security that way. Okay, so now we understand what kind of vulnerabilities, we have a good idea about that. So let's take a step back and just look at a high-level view of SaaS tools, how they work. So as I mentioned before, SaaS tools require static source code. So you see there's a source code there in the diagram. The source code is passed through the SaaS tools for scanning. And you'll see the tool is made up of rules and analyzers. And so now these rules they could be predefined rules that come along with the tool out of the box, or they could be custom rules that the end user may have added. And then you'll see there is a bunch of analyzers there. So think of analyzers as just some programs or algorithms which use these rules to scan your source code. And we'll just zoom into a little bit on analyzers in the next slides. But for now, just think of them as some algorithms or techniques that's used to scan your source code. So once your source code is scanned, the tools will generate a report. And the report will tell you what kind of vulnerabilities it's found, the exact line of code with a reason and some explanation, and possibly how you can fix it. So it's pretty explanatory there. After the report, you'll see there's a human review. So these SaaS tools are not 100% automated, unfortunately. It's after you run the tools, you're not done with it. There has to be a human who has to come into the picture and manually review these problems one by one, investigate if they are true issues or not. And if they are true issues, of course, somebody has to go and fix them. And then the cycle continues. And then you'll again run your source code through the tools. So let's just zoom into the analyzers a little bit. Now, the cool thing about these SaaS tools is that as an end user, if I'm using a SaaS tool, I don't necessarily need to understand how these analyzers work under the hood and what techniques they use. So all I need to know is that how to configure these tools, and as long as they're generating good bugs for me, that's all I care about. But just to get a good understanding, let's see what techniques they use. And again, these techniques could differ from tools to tools because not all tools support all languages. And every language is different. Every language is based on different infrastructures. They have different semantics. So these analyzers will also be different. The first one on my list is pattern matching. Again, this is not very rocket science. It's pretty a simple technique that some of these analyzers follow. It's called pattern matching, where there's a list of patterns which are known to cause certain vulnerabilities, and all these tools look for certain patterns, and they'll point to those patterns for you. The next one is data flow analysis, and this is very good at finding security vulnerabilities because this looks for tainted data in your code, which could be user control data. It could be coming from user input or from some external source like a cookie. Now, if it realizes that this data is tainted, it's going to follow the data and see how it's being used. So I just got this screenshot from one of the SaaS tools, and you'll see that the data is being propagated, which is tainted, and it's directly being used in a SQL command without sanitizing it. Now that could lead to a SQL injection attack. So that's something these tools can pretty easily report. Another technique is semantic analysis. Now there are certain APIs or functions which are known to cause vulnerabilities. For example, in JavaScript, if you have heard of the function called eval, what it does, it just takes in any arbitrary JavaScript code and it just executes it, no matter what JavaScript it is. It doesn't sanitize it. It doesn't look for any problems in the JavaScript. All it does is just takes it and runs it. So now if you're using eval in your code, that could, and if your user's data is tainted, then that could lead to disastrous consequences. So the semantic analysis, it looks for those kind of functions in your, or APIs in your code, and it'll tell you that to ask you to use some alternatives or to sanitize your data before that. The next one is control flow analysis. So this kind of analyzer, it looks for dangerous sequence of operations. So if you look at the example here, on the left side, there's a use case 1. It's a very simple program where we're checking for null. If x is not null, then we perform an operation x.foo. That's fine. If I run the SaaS tool on this, it's not going to report any bugs. But if you look on the use case 2, the programmer forgot the sequence and he called function foo on x before even checking for null, right? So these control flow analyzers are pretty good at finding these kind of operations where the program may have forgotten to add null check before using it. Of course, this is not the complete set of analyzers. This is some just a partial list. Okay, so now let's take a look at some of the examples of SaaS tools. Now, if you just Google for SaaS tools, you'll find a huge list of SaaS tools out there. There's a lot of tools in the market. There's some are commercial, some are open source, some are for specific languages or frameworks, some support a lot of popular languages. So I'm not advocating any of these tools again. So just feel free to go and look for yourself, whatever fits your needs. And there are multiple ways to run these SaaS tools. One of the ways is command line, which most of the tools offer. Some of the tools also offer a GUI client. So you can go and add a project using the GUI client. You can configure your project, you can configure your source, and then you can also scan your code using the GUI client. It also generates a report which you can view in the GUI client. So that's pretty cool. Again, some of them also offer IDE plugin. I know a couple of them do, like SonarQube and there's Puma Scan. So they offer IDE plugins that integrates with your IDE. So again, that's pretty cool because it integrates with the developer pretty early on in the cycle. So as the developer is programming, at compile time, it's going to look for security vulnerabilities, and the programmer can fix them right there, right then. So it's pretty early on in the cycle. The last but not the least is a continuous integration, and that's the ideal way to run your SaaS tools because that's going in the direction of DevSecOps. You want to automate everything. So we'll talk about DevSecOps towards the end, so stay tuned for that. Okay, so let's talk about some of the benefits of using SaaS tools. So in my opinion, the first benefit of using SaaS tools is that it integrates in the implementation phase. So it is pretty early on in the cycle. You don't have to wait until you run your application, right? All it needs is a static piece of code. So you can do it while you're programming, and it finds problems much early on in the cycle. It scales well. Humans are very good at finding issues, but I can maybe scan only 100 lines of code in a day. But now when you have thousands and millions of lines of code, that's when you have the SaaS tools, which does the job for you. There are many tools available out there. As I mentioned, if you Google for it, you'll find a huge list. And especially when you're using one of these popular programming languages, you should be able to find a good tool. And these tools are very easy to learn. You don't require special skill sets. All you need to learn is how to configure them, and that's usually pretty straightforward. One great point about the SaaS tools is that it will pinpoint the vulnerability in your source code, give you the exact line of code, and it also gives you a good explanation of why this is a security vulnerability and possibly how you can fix it. So you don't need special skill sets. You can just easily go and fix it. Some of these tools, actually all of these tools come with a standard set of rules, and they may not be enough depending on your requirements. Especially when you want to advance some best practices within your team, you may have certain coding standards, or if you want to advance those, then you may need to add certain custom rules on top of those. And these tools provide that ability to do that. And static tools, in my opinion, are the perfect choice for continuous integration, because all you need is a static code, and you can easily plug it into your CI pipelines. Okay, do SaaS tools have any limitations? So yes, they do, because everything has a flip side. SaaS tools also have some drawbacks. One of them is it may not support all the languages. So if you are using a very brand new language, or if you're using a very unpopular language, you may not be able to find a tool. So if you're starting a new project, if you are looking at picking a language, then that's something to keep in mind. Another limitation, or maybe just an overhead, is that you will need to make sure that your tools are up to date. So your technology keeps evolving every time, right? Like there's new versions come out, there's new features that get added to your languages, your frameworks. And that also opens up doors for new security vulnerabilities. So you have to make sure that your tools, your SaaS tools, are in par with your technology. So there is an overhead of because you have to keep upgrading them to keep in par with your technology. One limitation to keep in mind is that SaaS tools will only find security bugs. They will not find security flaws. And there is a difference between the two. Security bugs is implementation level bugs. Now, security flaw could be a more design level flaw. Now, just to give an example, imagine there's a piece of functionality in your application which is supposed to be protected by some authorization code. Now, if the programmer forgot to add that authorization code before the piece of functionality, there's no way these SaaS tools would understand that this piece of functionality was supposed to be protected. So that's a design level thing, right? So the SaaS tools have no idea about the designs. So that's something that you have to keep in mind. And of course, there's other tools to do that for you. And you may need to add custom rules based on your requirements. And another thing, you may have to fine tune it a little bit to work the way you want it to. So there is a little bit of overhead there as well. And sometimes what happens is when you run these SaaS tools, you get a very false sense of security that, hey, since you ran these SaaS tools, you're all security proof. Nobody can cause a breach now. But that's not 100% true. Now, these SaaS tools, after all, they're just tools, right? They can only do so much for you. They can have some false negatives. So you may have some bugs in your code which may not be detected by SaaS tools. And again, there could be a lot of bugs that get detected, but they may not be true problems in the real world. So sometimes your true problems, when you're going through these false positives, your actual problem may get lost, right? So that certainly could happen. So let's take an example of the false positive. So you see this is a JavaScript function. It's a very small function. I'm just defining a constant, and the name of the constant is password, and I'm assigning it to a string password. Now, in this context, I'm not using password in the real sense, right? I don't have an actual password hard-coded here. I'm just using it as a type. So when I ran the SaaS tool on this piece of code, it said that this is a security vulnerability and consider encrypting your password. So this is a false positive. In a real world, it's not a true issue, right? So that's something that I may have to go and fine tune it and tell the tool that, hey, this is not a real issue. The next one, let's look at a false negative. So this is a small piece of JavaScript function. It's called change div. Now, if you look at it carefully, all it does is it takes a DOM element by ID and it assigns its value to cookie. Right? So when I ran the SaaS tool on this, it said that there is a cross-site scripting error and the tool reported correctly, right? Because it's absolutely correct. You're taking in a cookie which could be malicious, it could have bad JavaScript, it could also have a bad URL, and that could lead to a cross-site scripting attack. Now let's look at another code. And what I did, I just copied the same code, but I just made it a little bit more convoluted. Now, if you carefully look at it, it does exactly the same thing. Okay? It just takes in there's a global variable. Okay, you set the global variable to cookie, and then you get the global variable back. So you get back the cookie, and then you assign it to the DOM element. Right? But now, since the code, when I look at it, actually, I have a difficulty following it. So now, when I ran the SaaS tool on this piece of code, it said that no issues found. And that's a false negative. And the thing is that now some of these SaaS tools, the algorithms, the way they're designed, is they're designed to work empirically, right? And they have a lot of trade-offs. Now, if this was detected, then there could be many other false positives, right? So they try and balance out the false positives with the real issues. So when you're passing something, a tainted data through a function, and then doing something, then it usually assumes that the tainted data has been sanitized, because that's all it can do. Right? So that's something to keep in mind. And of course, now we saw SaaS tools has a lot of benefits. They also have some limitations, but some of these limitations can be overcome by following some other strategies. And that's something Gal will talk about.
So we went over SaaS. So let's go over the other side, the other strategy we have. It's Dynamic Application Security Testing, or DAST. So what is DAST? Actually, just a quick recap. So it's the black box approach. It will run on your running applications, and it can find your vulnerabilities from your configuration and your runtime issues. So what does DAST check? So first thing, it will check your memory usage. So first, it will check if you're using too much memory or if you're exposing data you're not supposed to be exposing. It will check your encryption. SAST will check that you're using encryption. DAST will try to break your encryption. So if you're using a weak algorithm, it will try to break it, and it will probably succeed. It will check your permissions. It will try to gain elevation of access and get super user permissions on a rooted device. And obviously, if you can get that, it can hack your system. It will check code injection, again, top 10 OASP. It will try to inject in any input field everywhere it can. It will check your performance. So it's not necessarily security related, but you want your performance to adhere to industry standards. And obviously, we'll check your configuration issues if you have SSL, TLS, what versions, HTTP and HTTPS certificates, and things like that. So a quick high-level view of DAST. So obviously, it's running on your application. So it's going to need your application, your databases, all your microservices running and configured correctly. It will talk to your application and generate a report. This report will tell you what vulnerabilities it found, but it cannot tell you where in the code it is because it doesn't have the code. Obviously, you have to review any false positives that you have and fix all the critical issues, build it again, deploy, and run round robin. So a little bit about how DAST tool works. The first three approaches are not pure black boxes because they actually do need access to your code or to your libraries. So the first one is source code instrumentation. That means the DAST tool will actually add pieces of code to your source code and use that code to expose data it needs to know. The other one is object code instrumentation. It will need your libraries, and while you're building it, again, it will add data to your application to expose data. The third one is more a C and C++ GNU. It will add code during your compilation stage with switches. The fourth one is the pure black box. It does not need any access to your code. You can run it on your integration environment or your staging environment without touching any other parts of your CI. So we went over this again, just a quick recap. What vulnerabilities DAST can detect? Obviously, injection. It will try to inject and find it. It will try to find broken session management. It will try to access a URL that it's not supposed to access without a session. It can find sensitive data exposure. It can't find it in the code. But if you're saving username and passwords and cookies, or you're passing it in URLs without encrypting it, it can find it. Broken access control, it can try to run malicious cookies or things like that in code and break your access control, and obviously cross-site scripting, sorry. So what results do we expect to see from our DAST tools? So resources consumed. So you can see how much resource your application is used, memory-wise and CPU-wise, or if a specific model in your application is using too much memory or too much CPU. It might be worrying if you have a model that's consuming too much. It can find program errors, things like division by zero or Y2K bug, not relevant now, but it used to be, and null pointer references. Again, it can crash your system, so that's a vulnerability. And it can generate compliance reports, because a lot of our systems need to be compliant with standards. So again, some of the DAST tools available, there's a lot more. Not supporting any, not against any. So what are the benefits of DAST tools? So false positives are rare, because if it does find an error, usually it's there, there's a problem. I'll talk about when you can have false positives in the next slide. And source code is not needed. You can run it on a totally different application. It's very easy to just have someone that is not programming just running it on a different application. So what are the limitations? So the tools are only as good as you make them. You have to define what routes the tool is going to go through. If you miss a route, the tool cannot find it. It does not check code correctness. So the same as SaaS tools. If you have a security flaw in your design, it will never find it. It requires resources. So by requiring resources, usually you want to run it on your integration environment because it will overload your network. It will try to crash your system. You do not want to use it on your running application. But because you run it on your integration environment or your staging, you might get false positives because usually these environments are not set up the same way as your application actually is. You might have certificate issues or HTTPS versus HTTPS and things like that, and those are false positives, obviously. And because it's actually running, it can only do one execution path at a time, so it can take time. So that's another resource that can take, especially for complicated systems. And obviously, you don't want to run it on your real systems, so you need another environment. So a quick breakdown about static versus dynamic, what their strengths are and what their faults are. Not going, we went over all of this, just a quick recap. So obviously, static and dynamic should be used together. They complete each other. So we need them both for a good comprehensive testing. So I know this looks like I copied it from Tanya this morning, but she doesn't have MAST. So, so interactive application security testing, or IAST, it's tools that more or less take static approaches and dynamic approaches and combine them together. It will run the static first and then the dynamic. And by that, you will actually find less false negatives, because if it finds a possible vulnerability on the SAST, it will check if it's actually a vulnerability in DAST. Runtime application self-protection, or RASP, it's actually a tool that will run side by side your application and check for any malicious user activities or any network issues that you can have, and it will report it to you. And mobile security testing, at least I have one that she doesn't have. Today we write a lot of mobile applications, and these mobile applications have their own set of security vulnerabilities. So these tools will check for things that are relevant for mobile devices, like things like jailbreaking devices or rooted devices, spoofing Wi-Fi's, invalid certificates, and things like that.
All right, so let's talk about DevSecOps. So what is DevSecOps, first of all? So it's security embodied in your DevOps model. So in the past, what happened was there was a dedicated security team that used to perform security activities, and the developers and the operations didn't care much about it. But now with the new model, they say that security has to be a part of every phase of your DevOps cycle. So everybody is accountable for security. So to achieve that, now you need some tools, right? So how do you incorporate security in your DevOps model? So we have we generally use CI pipeline. So this is a very typical CI pipeline that you can see. Of course, your pipeline may be different based on your application types. So you'll see there's a bunch of developers down there who are contributing to the source code. And then above that, there's a Jenkins. That's a CI tool. Of course, you could have any other tool. In this case, I have Jenkins. So Jenkins is going to pull the source code from the source code repository. And the next thing that it'll do is it'll try and build the code. Now, if all goes good, then the next step would be unit test. Again, all that is very typical. Then you run the unit test, and if everything passes, then you go on. If the unit test failed, then of course you go fix it, and then you rerun the cycle. So the next step you see is static code analysis, and in my opinion, that's where it fits the best. After you run the unit test, that's something you would do next. You would run the static code analysis on your source code. Now, as we mentioned before, there are some limitations to static code analysis, and one of that was false positives, right? You may have a lot of false positives, and sometimes if you have too many of it, it could be a hindrance to your cycle, right? Because with the DevOps model, it's a continuous integration, right? So you may have several cycles, and you don't want to stop your cycle every time you check in some small piece of code, because there could be false positives. So what is the solution to that problem? So there's one thing that you can do is you can add a quality gate. And some of these tools provide a mechanism for quality gate. So with quality gate, all you're doing is you're specifying a threshold. And you can say that, hey, only if the vulnerabilities cross this threshold, then I want to break the build. Otherwise, if it's under the threshold, then I want to just give the green light and I want to go forward. So imagine now you may have, some enterprise may just say that if there's even one critical bug in my code, then I want to stop the build. Or if I have any medium or low severity issues, then I'm totally okay with that. I just add it to my back bucket, and then I want to move forward with the cycle. So assume everything is all good, you met the quality gate, and that gate is opened. So the next step would be you'll go to build your application. Right? In this case, it's a build Docker image. In your case, it could be build installer or anything else depending upon the type. Now, after you build your Docker image, the next step is you deploy your application. Right? So you're all ready to deploy. And then you'll see there's a dynamic code analysis after that. And you see it's a little bit outside the pipeline. And the reason is because it's sometimes not very straightforward to have dynamic code analysis in this CI pipeline, because now for dynamic code analysis, as Gal mentioned, you need a running application. Okay? If you have one small running application, that's fine. But in modern systems, you generally have your application talking to different services, different applications, different databases, and you need to have that kind of infrastructure ready for it, where you can deploy all the pieces of your ecosystem and then test. Because dynamic code analysis requires your whole application running as if it's running on production. Right? It doesn't work on mocks. Another problem that Gal mentioned was dynamic code analysis. It requires a lot of resources because it's like an attacker who's trying to attack your application, right? It's simulating an attack. It could require a lot of resources like memory, CPU, and you may not have that kind of infrastructure ready, especially when you're running the cycles very often. Right? So that's why sometimes you may see that dynamic code analysis is not a part of the pipeline, and some people just end up running them manually. Okay, so how many of you are already using SAST or DAST tools in the audience? Okay, that's quite a few. Okay, so people who are not using these tools, say if you want to go back home and decide that, hey, you want to start using these tools, how do you get started? What is the first step that you should be taking? So first step, in my opinion, is to first look for the technology, right? Because not all tools out there support all the technologies. So that's the first thing you would look for. The next thing is, of course, there's many tools. Some are commercial, some are open source. Your budget could be an issue, so that's something, another thing to consider. A very good feature to look for is if the tool can group issues based on severities. So some of these tools, they can group, they can form buckets, that these are all critical issues and these are high severity or low severity issues. And if the tool can do that, that really helps the team or the programmers to prioritize issues. And again, it also helps with the quality gate that I mentioned before. So for some enterprises, fixing critical bugs may just be the highest priority, and they may just want to put the low severity ones in the back bucket and worry about it later, right? That may not be a roadblocker for them. Another very cool feature to look for is ability to mark false positives. Now, as I mentioned before, especially when your code base is huge, you may have hundreds of false positives in your code. Now, imagine you went through all those vulnerabilities that your tools reported, you filtered out all the false positives from the real ones, you fix the real ones, and you rerun this whole cycle again. Now, if the tool may pop up the same false positives every time you run the code, right? So you want the tool to remember that, hey, these are the false positives, and I'm not supposed to show these again because this is not a real issue. So that's something to look for. And the last one is a very important one, is to look how easy are these tools to integrate in your CI pipeline. Because that's the direction we should be going, the DevSecOps. So make sure that they have plugins available for your Jenkins pipeline, or make sure they have the feature for quality gates. That's something that you should look for. Okay, so to diagnose or to not to diagnose is a question. Now, there are some drawbacks of using the security code analysis. We know there are some false positives, there are also some false negatives, and also there's added cost because somebody has to go and investigate each issue, filter out the false positives from the real ones. So there is an added cost. But in my opinion, security code analysis does provide a very solid layer of security on top of your application. It's not everything that you need, but it does provide a good protection, and it takes care of a lot of low-hanging fruits for you. So
So does anyone think it's enough? Show of hands. Good. So SAS and DAST are not enough. So when you start, your design should go through a thorough risk assessment and check any vulnerabilities, how your models talk to each other, what data they expose. You should also do a database security scanning. A lot of us are using all kinds of databases, but you want to make sure your database is up to date and doesn't have any old vulnerabilities, that you're saving your data encrypted, and that your passwords and usernames are not obvious. You want to have good test coverage analyzers. As Masuma said, quality equals better security. The higher test coverage you have, probably you have better quality. 100 obviously is the aim, probably not. You also want to check that your dynamic code coverage is good. Your dynamic testing code coverage is good. You want to check exposure of credentials. You don't want to keep any of your credentials anywhere hackers can access. The Uber hack happened because Uber was saving their AWS credentials in GitHub, and the hackers got access to GitHub, they got their AWS credentials, and then they hacked into Uber. And you want to validate third-party libraries. A lot of us are using third-party libraries. They might be encrypted, and you might not know what's going on. But Node had a third-party library that was encrypted, but behind the scenes, it was actually mining Bitcoins. So you want to run third-party library checks on your third-party libraries and make sure you can use tools like Black Duck. That's it. Thank you. Questions?